I also think something like, I think I can. I do like the game that have like the arcade where you like smash a soccer ball. I love doing soccer.
I think if I finish the notes on page 9, so if I can do that for we talk about the next section here. Okay, so your Taylor polynomial, the whole idea is that we're gathering information from the function to put into the polynomial so that we can create something that mimics the curve, whether it's exponential function, e to the x, or cosine, or sine, or natural log. So we talked about how Taylor polynomial kind of follows this form that is the nth derivative evaluated at the center, and that center is wherever could be 0, but also could be whatever center that provides you, over n factorial times x minus c. Yeah. And the coefficient is just whatever is sitting in front of the variable. This whole thing is the coefficient. All right, so let's see an example of that. For number 3, it says, let f be a function with a third derivative, given here. What is the coefficient of the fourth term in this fourth degree polynomial centered at the x equals 2? So that's my c value. So that means if I want to find anything involving the fourth degree polynomial, I need the fourth derivative, right? But nice thing is they give us a third derivative. We just find one derivative further. We don't have to find from f of x all the way to the fourth derivative. Just have to go one more derivative down. So that's fine. Let me just set this up here. So the third derivative is 8x plus 2 to the 3/2. And so the fourth derivative, I can just rely on what? Chain rule, right? So chain rule outside derivative times the inside derivative. And so my fourth derivative is, I could do 3 times 8, which is 24. 24 divided by 2 is 12. So I can evaluate the fourth derivative at 2, and that will take care of that the f to the fourth derivative at c. So I can say the fourth derivative at 2, just plug 2 into my fourth derivative. So 2 times 8 is 16. 16 plus 2 is 18. So 12 times 18 to the 1/2. I can clean this up a little bit here. This is really 12 times square root of 18. And 18 can be broken down into 9 and 2. And I can take this square root of 9 out as what? 3. 12 times 3 is 36. So now, if I wanted to let me build out my entire fourth term. So this divided by 4 factorial times x minus 2 to the fourth. I'm just going to write everything out, and then we can just pull the factorial, pull the coefficient out. Okay, so this is my entire term, but if it's just asking for the coefficient, this is all I need to pull. I'm going to clean this up as much as I can here. So 36 root 2, 4 factorial, same thing as 4 times 3 times 2 times 1. If I reduce that, 36 divided by 12, this will give me 3, right? So 3 root 2 divided by 2. Okay, were there any problems from the homework on page 8 to 13 that you want me to go over, that you were stuck on? I try to make my key as detailed as possible so that hopefully things are easy to follow, but let me know if you're stuck on any problems or any questions that was not clear. Okay. All right, you can always ask me later. Let's go into 10.8A notes. So this is page 14 here. Uh, we're gonna recognize a lot of this process. We've been kind of practicing it even during our quiz unit. We call this a power series because these are all x raised to a certain power, x1, x squared, x cubed, and a lot of it kind of falls into, kind of reminds us of geometric series as well. So this would be a power series that is centered at c equals 0. And then if I have x minus c, that means this center is going to be potentially at a different spot. Could be c equals 2, c equals 3, c equals 4. Typically hold on to those c values if it's other than 0, but if it is 0, we usually let it drop out. It feels a little bit cleaner to build out. So the domain of a power series is a set of all x values for which the power series converge. Note the center is always part of the domain. So here are, these are 3 ways that a power series may converge. So first off is that your power series is always going to converge at the center. So the center is always going to be guaranteed. Even if everything fails, we know that at the very least, we're going to converge at the center. It's like a parabola and a straight line, right? Even if the line is not going to do any better with any other point with the curve, it is still at least going to touch that. It's still going to be tangent to the graph at that point. So it'll still converge at that point. So it can converge to an interval. The radius is the distance from the center to the edge of the interval. The thing we have to watch out for is when we find that interval, we always have to make sure we test the endpoints because the endpoint may or may not converge. And so we have to look at each endpoint individually. We can't assume that, oh, if one side converges, the other side is going to converge. The endpoints are always going to be independent of each other. So when we find our potential interval of convergence, we still have to make sure we test our endpoints. It can converge to all real numbers. That's possible where it doesn't matter what the x value is, it's always going to converge. If that's the case, then our interval will be negative to positive infinity. And it's possible that our series may only converge at the center because it diverges everywhere else. So the test that we're going to use more often than not than anything else is going to be the ratio test because these are all power series. These are all exponential powers, and exponential powers is handled best with ratio tests. So we're always going to do ratio tests for power series. So if we have a power series, then we find the limit as n approaches infinity of a sub n plus one over a sub n. But now we're going to have an unknown x value in our power series, and we have to figure out what is that unknown x value that will allow us to show convergence. So basically, we're going to set everything up like what we've seen before. We set it to be, we're going to evaluate the limit, and if our limit is less than one, then our series will converge on an interval. This will be where we have all the n's canceled out, and we have like x plus 3 is less than 1, then we can solve for x. If our limit has n left over, but n is in the denominator and it's equal to 0, then it doesn't matter what the x value is. We're always going to be able to converge. We can say our domain is all real numbers. But if we go through the ratio test and we realize that n is in the numerator and it goes to infinity, then we know that it's going to diverge everywhere where x, doesn't matter what the x is, except the center. So we're still going to be protected at the center. We may have everything else diverge, but we're always going to have convergence at the center. So no matter what the scenario is, we're always going to have convergence. It's either it's going to be on an interval, is it going to be for all real numbers, or is it going to be nowhere except the center?
If the limit is negative infinity, then it would be on an interval.
Say it again.
If the limit evaluates to negative infinity, would it be on an interval?
Oh, well, we're talking about absolute value here, so it's always going to be a positive. Yeah. Positive. Let me just give you 3 quick examples so you can kind of see what these look like before we jump into it. So for instance, if I had limits as n approaches infinity, and let's say ends up giving us, x over 2 times n over 2, this one would be a situation where the n's not going to cancel out. This is going to go to what? This is going to infinity, right? That n is not canceling out nicely. So this is going to converge or it's going to converge only at the center. This is the third scenario here. And then the second scenario here, let's say I had limit as n approaches infinity of x over 2 times 1 over n. This is always going to go to what? 0. So if it goes 0, it doesn't matter what the x is. This is always going to converge. So it's going to be from negative to positive. In the third scenario, this is going to be the one that we're probably going to see the most often. If I had x over 2 times n over n plus 1. This one, the n's will cancel out. So this, we can find the interval of convergence. And we can, we can build from here. And so this will be the first scenario where we can actually create an interval with left endpoint and right endpoint. So it really depends on what happens with the n, right? Usually we're going to be in this scenario, but we just have to know how to adapt to these 2 scenarios. All right, so let's look at page 15, and I really feel like this will feel very familiar because we've been doing versions of this, even at our quiz level, even with our previous 10.1 and 10.6. Okay, so number 15. I'm sorry, page 15, number 1. Find the radius and the interval of convergence. So one thing I did not show up in the notes is this idea of absolute value of x minus c is less than r. Whenever we get our absolute value down to this form, just know that whatever is to the right, this is basically indicating your radius here. And then the c is your what? Is your center. But it's the opposite sign, right? So for instance, if I had x minus 2 is less, absolute value of x minus 2 is less than 4, my radius is 4, and my center is what? 2. Yeah, so it's always going to be the opposite sign of what you see inside your absolute value. Okay, so let's build this out here. We're going to be using ratio tests for all of these. And we're basically trying to find the x value that will allow us to have convergence. Okay, so we'll do the limits as n approaches infinity. So ratio test, I'm going to do a sub n plus 1 divided by a sub n. Divided by my original a sub n. So let me do some rearranging, do some cleanup. Now my n plus 1 and n will go away because limit as n approaches infinity. This is just going to go to 1. So what's left? Half the value of. Yeah. So we know this is going to be a nice interval here. We can bring that 3 over to the right side here. So this is absolute value of x minus 5 is less than 3. My center is what? My center is 5, and my radius is, okay. Okay, let's just solve this like we've done before. We can drop the absolute value and we can do inequality with -3 and 3 on both sides. Add 5 to all the terms. We can get x by itself. Okay, so this is our potential interval of convergence. We still have to test what? Test the endpoints. So the way we test endpoints is we plug 2 back into the original series and see if it'll get us, remember we're plugging in for x here, and seeing if it will converge or diverge from there. So I'll test x equals 2 first. Two minus 5 to the n, that's -3. So I have n times -3 to the n over 3 to the m. If I pull that -1 out, I'm still left with n times 3 to the n. So it's an alternating series, but n is up top. So will this converge or diverge? Diverge, right? It's not like 1 over n where it's going to go to 0. That n is going to keep increasing up to infinity, even but this is an alternating series, but my condition doesn't approach zero, right? So my limit doesn't go to zero, so this diverges. So we know we don't have to keep this one in our interval. If I plug in 8 minus 5 is 3, 3 to the n, the 3 to the n cancels out, I'm still left with the n. So do either side converge? No, so we can leave the 2 and the 8 out of it. So our final interval of convergence is 2 to 8 without the 2 and 8 included. Any questions?
What would the interval be?
Just from 2 to 8. Without, so we would not do less than or equal to, we would just do less than for both these.
If they converge, then you'd add the less than or.
That's right. If they converge, if either, yeah, so remember, these are independent. So if we test one, we gotta test the other one as well. Could be one converge, the other diverge. It could be any scenario, but if it does converge, we would just put an equal sign where that point works. Okay, so we're just gonna do as many examples as we can. So let's try number 2. It's also asking for the radius, so just make sure we can state that as well. Okay, there's my a sub n plus 1 divided by a sub n. My series does not have a fraction, so that makes it easier. I can just put them over each other. No n's to cancel out. X minus c is less than r. My radius is 1. My potential interval convergence is from 1 to 3. So I need to plug in 1 to see if that converge or diverge. Plug in 3 to see if that converge or diverge. Yes. It diverges because if I plug 3 in 3 minus 2, I get 1, 1 to the n. The limit as n approaches infinity of this is still going to be 3 plus 3 plus 3 plus 3 plus 3, and that diverges, right? All right, any questions with 2? All right, let's try 3, 4, and 5. let's see how we do with that. I'll walk around, see if we have any questions. You guys also have the key to the notes packet, so. Know about that and read that, to check your progress as well. Oh, for this one here? Yeah, center is at -2.
How do you know only x equals, like, how do you write 0?
I know 0, because that x squared is x, there's a hidden,
Um,
yeah. The center will be obvious to you. If it's X, yeah, if it's not centered at 0, then, yeah, it'll be like this. This is obvious where that center is. It's always gonna be attached to a number.
And plus two. Why not plus one?
Right, so, we want to find the next term here, so it's x to the 2 n plus 1. Right, so we do need to, yeah, good question. We do need to, place the n with n plus 1, but if there's any coefficient in front, we need to distribute it through. So that's why. Notice for number 4, the ends up in the numerator are not balanced out with the denominator. There are more ends up top and below, so n is, as n goes to infinity, this entire expression is going to go out to infinity. So we know that this will diverge everywhere except at the center.
It converges for all values of x, the radius would be.
Infinity, right. So for number 5, we see that the n is in the denominator. This is going to get closer and closer towards 0. It doesn't matter what the x value is. My limit is always going to go to 0. So if that's the case, I'm going to have conversions for all values of x. My radius.
Doesn't matter if it's an inequality or like, or like you have parentheses.
Oh, yeah, I think parentheses is going to be the standard way, so. Right, like this, oops,
Only for the infinity.
right, yeah,
Oh, for the second step of that problem, don't the n factorial. Over x plus one. To the n factorial.
you're right, should be n plus 1, thank you.
never mind. I was just, put it to 0.
Hey, let's try one more here. This is, page 16, number 1.
So -1 to the end, just -1 to the end with divergence, right?
Yeah, it'll diverge. Because, it's like saying this. Up and it's like 1, so pushing past that first stage. Because this would be 1 plus 1 plus 1. So limit, and then it goes to infinity. Now, if it was 1 over n, then that will go to 0.
What if it's like 3/4?
3 over 4, that is still going to approach. Sorry, I did not put the summation in front. It should be like this. If it was 3 over 4, then it'll be 3/4 plus 3/4 plus 3/4. So it'll be like this. All right, you guys will, finish off the rest of the pages there. Page 15 through 20 is your, homework. Can I get your phone? Thank you. If I may, yeah, thank you.